everybody, welcome back in for another math video, and today we're going to be talking greatest common factor. So in the last video I put together, we discussed factor trees, and we talked about what factors were, of course, talking about what the very smallest things were that you can multiply together and get a bigger number. Yeah. So that's going to be a big piece. So if you have yet to watch that factors video, that factor tree video that we put together, and also the prime and composite numbers video, that's going to be very, very helpful to watch those beforehand. But if you have a little background with prime numbers and with factors, you're going to be good to go. We're going to try to make this make as much sense as possible. So what we're talking about today, like I said, is greatest common factor, and it is what it says it is. Okay? So to start with, a factor right here is a number that you can multiply by another number to get a larger number. So for example, the factors of 16, if I were to list them out, I would have 1, 2, 4, 8, and 16. And if I were going to multiply some of these numbers together, I would say 1 times 16 would give me to 16. 2 times 8 would give me to 16. And 4 times 4 would give me to 16. I could also say, 8 times 2, I could say 16 times 1. I could flip the two 4s around. Wouldn't really make a difference, but I could do it. So, all of those things multiplied together get you 16. All of these numbers right here are the factors because I can multiply them by another factor to get that big number we started with. That's all you need to know right there. That's all a factor is. But there are times when we want to use those factors, and we want to use those prime numbers that we figured out in those factor trees, and we want to find out what the biggest number is, what that biggest factor is that two numbers have in common, or that three numbers have in common, or a whole series of numbers has in common. So how do we figure that out? How do we use those factors, and how do we use those prime factors to figure out what two numbers have in common, or what three numbers, or whatever a series of numbers happens to have in common? So first thing we need to do is we need some numbers. Well, what do you know? We just happen to have some numbers here. We have 36, we have 28. Those are the two numbers that we're going to start with today. And just like our last video we put together, we are going to make factor trees out of those. So this is already done for us. Okay, this is just an example. We're going to do our own in just a little bit here. But we've got 36, we have 28. So if I break 36 down, it'll break it down into 4 and 9. Neither one of those are prime yet, so I can keep on breaking them down. 4 is 2 times 2. Now what they didn't do here was circle them. I'm going to circle them just to show that it is the end of that branch of our factor tree. We're not going to have any other factors that come after that. 2 is prime, so I can circle that. Only factors of 2 are 1 and 2. That is it. Same with 9 over here. We broke that down into 3 times 3. 3 is prime, so we can circle both of those. That's the end of that branch. Okay. And then right underneath of this, they got all fancy. They said 36 equals blah, blah, blah. That's a lot of extra writing. We don't necessarily need to write that down. We just need to know 2 times 2 times 3 times 3, because we have a 2, and a 3, and a 3. Okay. Now, in our prime factorization video we did, we took these numbers and said, okay, here's an exponent. There's 2 2s, so I can say 2 to the second power. And there's 2 3s, 3 to the second power. That's not necessarily going to help us with these type of problems. If we're trying to figure out greatest common factor, it's actually going to be more helpful to have it written out like that. So that's what we're going to do. Okay, so we're going to leave it as 2 times 2 times 3 times 3. Okay. And we cross them off as we write them down just to make sure that we have them all. Okay. Then we can move on to number 28 right here. I broke that, or they broke it down here for us into 2 times 14. Maybe we could have done 4 and 7. That would have worked too. But in the end, it doesn't really make any difference. We're going to get the same prime factors either way. So 2 times 14, we circle 2. That's the end of that branch. 14 can be broken down into 2 times 7. 2 is prime, and 7 is prime as well. You notice I am moving pretty quickly through these. That's why I said if you have yet to check out the prime factorization video, it's a good idea to do that if you're not quite sure yet about these factor trees. So once again down here they wrote out the 28 equals. We don't need to worry about that. You can if you want to, don't have to. But we're going to write from least to greatest what our prime factors are. And we ended up with 2, 2, and 7. So 2 times 2 times 7 is what we're going to have there. Now, our next step is that we need to figure out what numbers both of these have in common. What are the prime factors in our list right here that both of these numbers have in common? Okay, so right here I'm going to just draw a line to make sure that we have two separate sets of numbers. These are for 36, and these are for 28. Okay, so what do they have in common? That's the question. Well, it looks to me like they both have a 2. So let's put a 2 up here, and we're going to cross off a 2. Make sure we don't use those again. Looks like they both have another 2. Cross those off, and we'll put a times 2. But that's all looks like they have in common. There's no 3 over here. There's 2 3s here. So there's no 3s in common. There's a 7 over here with 28, but there's no 7s over here with 36. So the only two numbers we have are 2 and 2. So to find our greatest common factor, the biggest number that both of these have in common, the biggest factor, the biggest piece, that building block that 36 and 28 have in common, 4 is our answer. 2 times 2 is 4. 4 is our GCF, our greatest common factor. Boy, that paper was very, very tilted there. Okay, so that's where we're at with that one. Okay, it's not so bad. It sounds like it's a process, and if you get some bigger numbers, it will take a little bit more time to figure out, but it's not so bad. As long as you can make a factor tree and you can see exactly what a set of numbers has in common, you're going to be in good shape. Now, one very, very important thing. If you've had me in class before, I've mentioned this multiple times, but right here. Okay? One thing that we need to remember is that when you're finding the greatest common factor of any set of numbers, that answer that you get, this final answer we got right there, cannot be bigger than any of the numbers you started with. If I would have gotten a number bigger than 36 or 28, that wouldn't have worked. Okay? Even if you have a set of 4 numbers or 5 numbers or 30 numbers, whatever your greatest common factor is cannot be bigger than what your smallest starting number is. Otherwise, it's not going to go into every single number. And by rule, that means it's actually not the greatest common factor. Okay, so keep in mind, whatever your final answer is has to be less than or equal to whatever your smallest starting number is. So in this case, I knew right off the bat my final answer was not going to be any more than 28, because that was my smallest number that I started with. 36 and 28, not going to be any bigger than 28. Okay? So keep that in mind. But let's take a look at a couple examples here. We're going to start from scratch. No work on these whatsoever. So our job that we have here is we need to find the greatest common factor for each one of these two sets of numbers. Start with a factor tree just like we did earlier, and now we're going to list the prime factors for each number just like we did. We're going to find which ones are common between the set of numbers, and then we're just going to multiply our numbers together. So we're going to take it step by step. We're going to work this out together. We're going to make it work. Okay, so if you would like to pause and do these on your own, excuse me, feel free to do so now. I'll scoot that up just a little bit so you can see which numbers we're working with. And if you want to pause and work those out, you are free to do so now. But I am now going to move this back down. We're just going to work on this set right here. 24 and 36 are my two numbers that I'm going to start with. So just like I said in the directions up above, I'm going to make a factor tree. So we need some branches, we need some branches. 24, different roads you could take. I'm just going to go 6 times 4. And I can break the 6 down into 2 times 3, which are both prime, so I can circle them. I can break the 4 down into 2 times 2. Both of those are prime, and I'm done with that one. So now I can write out what I have here, 2. I see another 2. I see another 2. And I see a 3. So those are my prime factors from 24. 36 over here, let's do 4 times 9. Again, a few different numbers you get it chosen. I'm just going 4 times 9. You can go 6 times 6, you can go 3 times 12, 2 times 18, any of those would work too. 4, I can break down into 2 and 2. 9, I can break down into 3 and 3. And that's the end of that one. And then I write them out. I see a 2 here, I see a 2 here, I see a 3 here, and I see a 3 here. So now my job is to figure out what they have in common. So I do see a 2 in both of these, so I can cross off a 2. Make sure we don't use those again. I'll put that up here. I see another 2 in both of them. Cross that off. There's not another 2 over here, but I do see a 3. And there's not a 3 in both, there's not another 2 in both. So right here is my set of numbers. Okay? So 2 times 2 is 4, times 3 is 12. And 12 is my greatest common factor for that one. Okay? So the biggest factor that fits into both 24 and 36 is 12. I knew the number was not going to be any higher than 24. In fact, it wasn't. Okay, so our rule still fits. All right, and our second example. And then we will get you out of here. So this time I got 3 different numbers. Okay? And they're bigger numbers than what we have worked with before. So we've got 80, we have 64, and we have 40. I'm going to break this one down into, let's do 20 times 4, or 4 times 20. Break that down into 2 and 2. That one's good. I can break that down into 10 and 2. So that branch is done. I can break that down into 2 and 5. And that one is done. So I will end up with a 2, another 2, another 2, another 2, and a 5. And again, we're crossing those off as I get them. That way I know that they are in fact done. I'm not going to reuse them. So that's my set there. All right, draw a line here. I'm going to try to separate these a little bit so we don't get the numbers mixed up. 64. Let's go 8 and 8. And then I can go 4 and 2, 4 and 2. 2's done, 2's done. I can go 2, 2, and I can go 2 times 2 right there. And again, we'll circle all of those. So we got a lot of 2's in this one. So we have 2, a 2, a 2, a 2, a 2, and another 2. 6 of those 2's are in there. Okay. So 64 is done. And then we have 40. The smallest number we have on here. So let's go 10 and 4. And we'll go 2 and 5. And that branch is done. And we go 2. Boy, that was a sketchy 2. Alright, but that is a 2. Nevertheless, as terrible as it is, that is a 2. And then we'll write them out. 2 right there. I've got another 2 right here. It's an ugly one, but it's there. I've got another 2 right here, and then I've got a 5. Okay. I ran out of room in that box, so I'm going to have to write down here. So, now we have to figure out which numbers all 3 of them have in common. So, 80. Looks like I've got a 2 here, and here, and here. Cross that off, cross that off, cross that off. Looks like I've got a 2 here, and also in my other numbers. So there we are. Paper's getting a little crooked there. All right, so 2, 2, 2. Do I have a third 2 in all of them? Yes, I do. So we'll cross off another 2 in all of them. Now I don't have another 2 in all 3 of them. So I can't go ahead and put another 2 down there. And I have a 5 in 40 and 80, but I do not have a 5 in 64. So that's just not going to work. I guess that means I don't have any other factors. No other common factors. So I can multiply these together. 2 times 2 is 4 times 2 is 8. And of those three numbers, 8 is the greatest common factor. So we got bigger numbers, but our greatest common factor, not very big. Size of the numbers does not make any difference. Okay? And a lot of times, if you have a wider set of numbers, there's a good chance that your greatest common factor is going to be on the smaller side of things. Okay? Because there's a lesser chance that there's going to be something that all of them share that is really, really big. Okay? So in this case, 8 was our final answer. So that, my friends, is the greatest common factor. Again, if you are in need, feel free to go back and check out the factor or prime factorization and the factor tree video that I just put up right before this one. There's also a prime and composite number video that fits in really, really well with this as well. So, thank you for watching. If you did enjoy, drop a like for me, let me know that you did enjoy it and that you found this video helpful. Otherwise, if you want to see more videos in the future, because I am going to be putting up more and more videos related to this and other math concepts in the future, do hit that subscribe button and ring that bell so you'll be notified when I do upload a new video. Otherwise, I hope you found this helpful. Thank you for tuning in. Thank you for watching. I hope you have a wonderful, wonderful rest of your day, rest of your afternoon, rest of your evening. Maybe you're watching this at 1 o'clock in the morning. Have a great rest of your whatever you happen to be at. And until next time, I hope each and every single one of you will take care.